Hello, 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 6.2, Law of Cosines. Alright, this is going to be a fantastically fast video because the Law of Cosines, we've already talked a little bit about it and when it's used in the 6.1 video. So let's jump right into it. We're doing this in the side case and the side angle side case. So we had four different cases of information that we could be given in a triangle. And we solved the first two by law of sines. We're going to solve the second two, these two, by the law of cosines. So we really don't need to wrap our heads around all six of these different formulas. One of them is fine. They're all the exact same thing. The only difference between this one, and this one is that each is solving for a different side. So this one's solving for side A, this one's solving for side B, this one's solving for side C. And the thing that we need to recognize here is that when solving for side A, I am taking the cosine of A over here, the cosine of angle A. And when I'm solving for side B, I'm taking the cosine of B. When I'm solving for side C, I'm taking the cosine of side C. So those things need to match up in the formula. The other pieces on the inside are just the remaining two sides. So if I'm solving for A, B and C are in the middle. If I'm solving for B, A and C are in the middle. And if I'm solving for C, A and B are in the middle. Okay? These alternative forms are simply the exact same thing as the standard.
That guy
reworked.
Little coat.
Reworked so that the angle is by itself. Because you're not always solving for a side length. Sometimes you'll be solving for angle A, angle B, and angle C. And they're just reworked in a way so that you can easily have your unknown on the left side and all of the numbers that you are able to put in and evaluate for on the right side. So let's take a look at how we can use the formula in a couple of different ways, and then we'll pretty much be done with this. We're starting off with a figure here where I have side A, side B, and side C. I have basically three different options, and that's kind of what I'm trying to decide is which option I want to go with first. And I guess it doesn't really matter. I'll go and I'll solve for angle B first. And if I look back, I'm solving for an angle, so I'm looking at the alternative forms because they have the unknown angle by itself. And I'm solving for B, so I'm going to use that one. Okay? So I'm going to do it in blue, sure. So when I do this, I'm going to have cosine B by itself, and that's going to equal A squared plus C squared minus B squared over 2AC. Alrighty, so now it's simply a matter of plugging in values. So what it looks like here is 8 squared plus 14 squared minus 19 squared over 2 times 8 times 14. That's a 4. Cool. Now we're looking at the cosine of B equaling all of this stuff. So this whole side is going to evaluate to a single number. Now my hope, and what I actually need to happen, is that this whole side evaluates to a number between -1 and 1. Right? This is just like one of the other examples that we did with law of sines. It needs to come out between -1 and 1 because the cosine only exists from -1 to 1. There is no angle value that I could possibly come out with that would be giving me a cosine value greater than 1 or less than -1. So if that doesn't come out correct, there's an issue with your math over here, and you need to go back and check it. But what this should come out to here is -0.45. Righty, so what that gives you when you evaluate the inverse cosine is that angle B is 116.8, which, if we just look at it, we should be able to say, okay, 116.8, that's an obtuse angle. B is an obtuse angle according to this depiction, so it appears that seems correct. Now let's look at solving for some other side. Let's see. How about we do A? How about A? And now that we have done the law of cosines here, I could go through and I could do law of cosines again. There's nothing stopping me from doing that. I could use all the sides, and instead of looking for b, I could go back and use this format and solve for side A, but it's a bit more cumbersome, I guess, than if I were to choose to do something like this. 19 over the sine of 116.8 equals 8 over the sine of A. Right? I just switch gears. Now I'm in the law of sines, which I know, I mean, just writing that out was a lot simpler. And now I can solve for sine of A. If I rework this thing so that the sine of A is by itself, what I'm looking at is 8 times sine 116.8 over 19, which is then going to give me 0.37, because this entire side evaluates to a specific number. And again, that specific number should be between -1 and 1, so that the sine can actually exist. And what that tells me is that angle A equals, should be about 22.28-ish. And from that point, I don't have to use law of cosines anymore. I don't have to use law of sines anymore. All I have to do is say 180 minus 116.8 minus 22.08 equals, which one have I not done? C? C. Fantastic. So when I actually evaluate that, C equals 41.12. Very cool. So the most important thing here was all of this. Can we, pick a specific thing to solve for, choose the correct formula, input the values correctly, and solve? I think everyone is very, very capable of doing that. I don't think that the law of cosines should be particularly difficult. The most difficult thing about law of cosines is trying to keep all of this stuff straight. But like I said, if you keep these things together, where what you're solving for and the angle are paired, you're solving for this side length, so it's this angle you're dealing with. As long as you keep those things paired, you should be okay. And like I said, keeping the alternative forms in your mind is not a necessity. You can always just input the values into here and rework the equation yourself. So that's the law of cosines. Do the assigned problems. Good luck. I know you'll do great. But if there are problems, we will go over them when I see you guys next. Have a fantastic time.
Neat, okay? Do it. Do it.